Hi everyone. Today we're looking at lesson 4.4, which is our last lesson in Unit 4 on solving systems of equations using the elimination method. We have already learned the substitution method, and we've also learned how to graph a system and find that solution, the point where they intersect. So here's our learning target for the day. We're going to be able to solve using the elimination method. So that's the part that's different. We're using a different method. And this time it's going to look a little different. We're still going to do it algebraically like substitution, but we don't have to substitute as much, and you'll see why. Okay? So let's go down and look right here at example 1. So first let's talk about what opposites mean. Like how do two things add up to 0? So take a moment to try and fill in those two blanks, pause the video, and then unpause to check your answers. So hopefully you're checking them and they are correct. Remember, 2 and -2 will add up to 0. 3 and -3 will add up to 0. 10 and -10 will add up to 0. Any number and its opposite will add up to 0. So how can we tell if a variable can be eliminated? And eliminated means add up to 0. Okay, so keep that in mind. Eliminated means add to equals 0. Okay. Is that the coefficients are opposite signs. Opposite coefficients. So as another example, if we had -5x and we were adding +5x, notice that the coefficients, the numbers in front, we have -5 and we have +5. They are opposites of each other. And that's how we know that they are going to eliminate, because -5 and +5 add up to 0. Okay? And this is the basis behind the whole elimination method. We're going to eliminate one of the variables so we can solve for the other. So let's look at an example of how to actually solve a system of equations and look at the process as we're doing that. So first of all, how do we know when elimination method is the best method to use? The first thing we're going to look at is to see that they're both in standard form. Okay? Both of them. Okay? Both. And that's a good thing to highlight there too. Standard form is ax plus by equals c. So where the x and the y are on the same side. So the first thing you're going to do when you're solving is to make sure that everything lines up. So line up your variables and constants. So line your x's up with your x's, your y's up with your y's, etc. Okay? Now we're trying to create opposites. So sometimes we might need to multiply, if necessary, to create opposite coefficients. For one of the variables. So if we're looking at the one that's down here at the bottom, we can see that -3y and -3y are both there. They're not opposites, though they're both negative. So how do we make something positive? We can multiply one of the equations, pick one, by -1. So I'm choosing the top one. Actually, you know what? I might choose the bottom. Yeah, I think I'm going to choose the bottom. And my reasoning behind that is it'll make the x's positive also. It doesn't really matter which one you do, but I like the bottom. So my top equation is going to stay the same. X minus 3y equals -16. And my bottom one, -1 times -5x is positive 5x. -1 times -3y is positive 3y. Don't forget your equal sign. And -1 times 8 is -8. Okay, now notice that they are opposites, -3 and +3. Okay. So now what we're going to do with these two is we're going to add the two equations together to eliminate a variable. In this case, we are eliminating y because -3 and +3 will add up to 0. And then we're solving for the other variable, in this case, solving for x. So I'm drawing a line under them and noticing that my x's and my y's need to line up as well as my constants. And I'm adding the two equations together. Okay. Let's see, so let's add the two equations together. So first remember that there's a 1 in front of this x. Sorry about that. A 1 in front of this x. 1x plus 5x is 6x. -3 and +3, they're opposites, right? So -3 and +3 add up to 0. There is no more y. It eliminated. That's the goal of the elimination method, that one of the variables should eliminate. And then we also have to add the constants on the other side. -16 plus -8 is -24. And now the last step, guys, to solve for x is just divide both sides by 6. 6 divided by 6 is 1. So 1x equals, and -24 divided by 6 is -4. Now I want to remind you that's not the final answer, because remember, every solution to a system is a point where they meet at. So we actually only have part of the answer. Okay, that's the x. Now we need to find the y. So this is where we have to use something we learned in the previous unit, in the previous lesson. We need to substitute. So let's fill in step 4. Substitute your answer into either of the original equations and solve for the unknown variable. So because we know that x is -4, I can replace x as -4 in either of the equations. The top one looks easier to me, so I'm going to use the top equation, but this x here is going to become -4. So x minus 3y equals -16. But I'm replacing x with -4. So see, now there is only y's, and I can solve for that y and get that y alone. So we don't necessarily need these parentheses here, so I'm going to get rid of them real quick. Okay. To get rid of the -4, we add 4 to both sides. -4 and +4, as we've always talked about, opposites add up to 0. So -3y equals -12. -16 plus 4 is -12. And the last step is division, and we will have our y also. We divide by whatever's in front of that y, -3. Anything divided by itself is 1, so we've got 1y, and -12 divided by -3 is +4. So now we have the y is +4. So I'm going to write my solution down here. Remember, we always write our solution as an ordered pair. X comma y, although occasionally it may ask you for just the x value or just the y value, but usually it asks you for the entire point. So our final answer is -4, 4. It is important, guys, that the -4 is first and the +4 is second, because remember, in a point, x always goes first and y always goes second. Okay, everyone, let's look at example 3. Now take a moment to pause the video and think about what number you would multiply one of the equations by so that you get opposites. Do you want your x's to be opposites, or do you want your y's to be opposites? So pause the video and think about it for a moment and then unpause. Okay, guys, so looking at example 3, hopefully you've thought about what you want to multiply it by. There's several things you can do, actually. I could multiply the bottom equation by 5, because that would give me a -5y in the bottom and a +5y on top, which are opposites. But think about it, isn't there another one I could do also? I can also multiply the top one by 2, because 2 times -3 is -6, and that's the opposite of +6. So I could eliminate my x's first or my y's. It doesn't matter which one. I'm going to eliminate x's because I already have it up there. So we're going to multiply the entire top equation by 2. So I'm going to get negative 6x, positive 10y equals 42. The bottom equation, remember, will stay the same. Make sure your x's and your y's line up. Now let's add the two equations together. Negative 6 and positive 6 add up to 0. And that was the point. Remember, this is called the elimination method. So we're trying to eliminate one of the variables. And we want, in this case, it to be the x's. Remember that this is actually a negative 1. So 10 plus negative 1 is 9, so 9y. And 42 minus 15 is 27. Last step, divide both sides by 9, and y is 3. But remember, that's not our final answer, that's only the y. I'm even going to go ahead and write it down so I don't forget and put it in the correct place. Remember, y goes second. And now I'm going to plug in my y. You can use either equation. I'm going to use the bottom one. No, I'm going to use the top one this time. You can use either. I'm going to use the top equation, the original. So negative 3x plus 5y equals 21. But instead of y, I replace just the y. The 5 should still be there. I replace the y with 3 and now solve for x. So pause the video and take a moment to solve for x, please. Check to see that you solved it correctly. Multiplying the 5 and the 3 to get 15. Subtracting 15 from both sides. And then lastly, dividing both sides by negative 3. Getting a negative 2 as our answer, and it's the x, so it went first in the ordered pair. So our final answer, the solution, is negative 2, 3. So now let's go ahead and look at example 3. We have a little bit of data. I want you to read through the problem, pause the video, read through the problem, and try and come up with two equations. This is a system of equations, right? So we need to write the equations before we can solve them. So try and come up with the equations real quick. Pause the video. Okay, guys, check your equations. Notice that each line is an equation. So Monday, the first website had 15 clicks, but we don't know how much money the advertisers get per click. That's what we need to find out, and we're calling that X. X is how much it costs, or how much they have to pay per click for website 1. And then website 2, there are 29 clicks on Monday. We don't know how much that costs either, that's why. And the total cost, though, is $94.15. Remember, total means it goes on the right, and both of these are in standard form. So to remind you, the X's and the Y's are how much money those companies are going to get per click. The first equation is the equation for Monday, the one that's highlighted in yellow, and the second equation is Tuesday's equation. And now we're going to actually solve. Notice that the Y's are very close. They're both 29Y, but we need them to be opposites. So we're going to multiply the entire bottom equation by -1, and then add the two equations together like we've done in all the previous problems. So pause it and try doing that. Okay, multiply the whole thing by -1 and then add the two equations together. Okay, guys, so please check the work that I have on here. You can see the first equation I just rewrote in blue, and the second equation I multiplied by -1, which really didn't change anything. All it did was change the signs of all of them. They all became negative. And then adding them together, 29y and -29y cancel out. 15 and -25 add up to -10, and $94.15 minus $121.15 is -27. Divided both sides by -10 and got positive 2.5. So 2.7, sorry. Now this should be money, how much money they're getting per click. So let's add a 0 onto the end to make it $2.70, which is what that really means. And remember, if we go back to the top, we can see that X is website 1. So I'm going to write that below, website 1. And what did the question ask for? What is the cost per click of website 1? Well, guess what? We just found the answer. We did not need to find Y, we only needed to find X. But remember, we could find Y if we wanted to, okay? So same as solving for normal systems of equations, but in a word problem, you have to create the two equations first, okay? If you have any questions, raise your hand and go ahead and get started on the practice that is posted in the Google Classroom.